Hi folks, Mrs. Gates here. Today we will be looking at the force of friction. Before we do that, let's take just a moment to review what we talked about last week with the force of gravity. Last week, when we studied the force of gravity, we looked at the relationship between an object's mass and the force of gravity, or the weight of the object. We found this equation, that the force of gravity on an object is equal to its mass multiplied by the gravitational field strength based on the location of the object. Today, we will be focusing on the force of friction. Recall that we defined friction as the resistive force that acts between two surfaces. You can imagine this on the microscopic level as tiny bumps on one surface resisting sliding against tiny bumps on the other surface. That means that this force is a shearing force. At the very basic level, there are two types of friction. The first type is static friction. Static means that things are not moving, and so static friction is the resistive force between two surfaces that are not sliding relative to one another. Remember that Newton's first law says that if an object is not moving, the net force on it is zero. The second type of friction is kinetic friction, or moving friction. Kinetic friction is the resistive force between two surfaces which are sliding relative to each other, like this penguin sliding against the snow. When an object is sliding and moving, there are two possible situations. Either it is sliding at a constant velocity. Remember, Newton's first law tells us that if something is moving with a constant velocity, the net force on that object has to be zero. Sometimes objects would be speeding up or slowing down, however, and in that case, the net force on our object will not be equal to zero. We will be using this PHET simulation in order to investigate friction today. In the simulation, you can adjust the force that is being applied to an object and measure the force of friction in each case. You can notice that in some cases, the object is not moving, and if you push it hard enough, the object begins to move. As you investigate the force of static friction, you will be collecting data about how the friction varies as the applied force varies. Once you have your data, you will be using that to plot on a graph the relationship between the force of friction and the applied force. To plot this graph, you will simply be moving this line over to your axis and stretching and shaping it as appropriate to describe the relationship between the applied force and the force of friction. The process will be similar as you study kinetic or sliding friction. In this case, you will be measuring the force of friction as you vary the applied force, and again, plotting this on a graph. In the last portion of this lab, you will play with the simulation in order to design scenarios where the object is traveling a constant velocity, where it is speeding up, and where it is slowing down. Use the speedometer indicator to help you determine what your object is doing in each situation. For each of these situations, you will record the applied force, the force of friction, the net force, and select the best option that describes the free body diagram for the object, as it is traveling at a constant speed, speeding up, or slowing down. Have fun and happy physicsing.